Okay, let's review factoring. We're going to look at the sum and difference of two cubes, excuse me. That's the one that kids tend to forget. You still need to remember GCF and guess and check also. Guess and check will be a trickier one, but I think you can get it. Okay, so this is a sum of two cubes. So you need a 2 parenthesis and then a 3 parenthesis. And then we take the cube root, which is x. You keep the sign plus cube root of 125 is 5. It's a little squiggly. Then you square the first term, which is an x squared. Square the last term, which is 25. Multiply those terms together, which is plus 5x. Change the sign, which is a minus 5x. I don't know why it's so squiggly, but there it is. Okay, I'm just going to do this one. 2 cubes. This one is a difference. This will be an x. Keep the sign minus. Cube root of 64 is 4. Square the first term. Multiply together, change the sign, that's a plus 4x. Square the last term, that's a plus 16. Okay, this page is going to be the answer to many, many, many questions. Okay, so this page is something you need to really look at here. Okay, so roots, factors, x-intercepts, zeros, these are all kind of interchangeable vocab, but they do mean a little bit different thing. First thing you need to know is the degree of the polynomial will tell you how many total roots there are. By total, I mean real, and I mean non-real or complex. Real roots you can actually see. They are x-intercepts. So in this graph here, if this is degree 3, this was from our homework the other day, there's 3 total roots, but I can only see 1 at -2. That means 2 of them have to be imaginary. And that makes sense because those come in complex conjugate pairs. Now, if -2 is the real root, then p of -2 is 0. That means when x is -2, y is 0, or it's an x-intercept. And that also means that I don't know if you can see this. I can hide it. It says x plus 2 is a factor. X plus 2 is a factor. You just change the sign. -2 is the x-intercept. So there are 3 total roots. 1 was real because you can see it, and the rest will be complex. Don't forget how multiplicity works. If it's a single root, it's a straight pass-through. This was a negative because it's frowning. You got to check the coefficients sometimes. It's really good to check things in your graphing calculator and see if it matches up. Double roots will bounce. So there's a multiplicity 2 here because it bounces, and then that one is a straight pass-through. This is a cubic. Don't forget that volume is length times width times height. And you need to know how to multiply factors to get to standard form. So just an example will be this guy. So that's an x minus 2 and an x minus, I don't know why it's like squiggly like that. I don't know if the batteries are going low. So this is an x minus 2. And that's going to be an x squared minus 10x plus 25. And then you will triple distribute, or you could do the boxes if you want to do that. Some of you like to do that. I'll do that just so you can see what it looks like. So it's an x and a minus 2. Oh my God. And then what I have here, an x squared, a minus 10x, you're probably laughing, and a 25, or else you're seasick. It's a 25. Okay. So this is x squared. So this is x to the third minus, I don't know what to do, minus 2x squared minus 10x squared plus 20x. What was this? A 25 plus 25 plus 25x and a minus 50. And then you just combine your like terms. So it's x to the third. And then on the corner, they match. Minus 12x squared plus 45x. And then minus 50. I'm sorry that it looks that way. I'm so sorry. Okay. And then the last question, number 9, is it's tough. It wouldn't be extra credit on the test, but you would have been, I think you would have had to ask questions on the review to have been able to get it. If some of you get this, I'll be impressed. Number 9 is pretty tough. If you feel totally stuck on some of these, that's fine. Remember, we're going for over a 50% or whatever. So just do your best. I got to figure out how to try to stop this now that I hid that.